Hey, so in this video, I'd like to go over a couple of selected solutions to some of the Brown level questions. Again, what makes something a Brown level question would be either if it required a metric conversion or if it involved the density of a liquid, all right, which when you're doing chemistry is something that you often have to deal with. I'm going to be a little bit quicker with some of this compared to previous videos. Just because at this point you should be a little bit more proficient in how to set up the crossbars. The first problem here, I'm going to kind of go through it step by step. All right, so first question said how many grams of aluminum would be required to react with 4.4 milliliters of H2SO4, and it gives the density of this chemical right here, which is called sulfuric acid. All right, so with all these problems, one of the first things that you want to do is go ahead and balance the equation right here, which I've done. And I've just gone ahead and written the molar masses underneath each chemical. All right. So what I'm going to do in this problem is just identify the chemicals that are involved. All right. You're starting with H2SO4, and we're going to aluminum. All right. So where are those in this equation? All right. H2SO4 is here, and aluminum is right here. All right, so when I start writing down my relationships, I'm just going to focus on things that involve these chemicals. All right, and I can tell that these are the only ones that are going to be involved because they're the only ones that are in the question. All right, so with any chemical, remember there's always two things that you can write about it. All right, a mole of that chemical is 6.02 times 10 to the 23rd of that particular molecule. Notice I did the same thing for sulfuric acid here, all right, and also with aluminum right here, all right. Again, this is atoms of aluminum because that's aluminum would be a single. That's an element. That's a single element, single atom element, and therefore it's atoms. All right. So you can also say that a mole is equal to the molar mass number of grams of that material. All right, notice I did that with H2SO4 here. I did it with aluminum right here. And then we have that glue relationship. So since we're dealing with these two chemicals, all right, we could say that 2 moles of aluminum, all right, notice that comes from this number right here, is going to be worth 3 moles of this chemical right here. I've got that number right there. All right, so what I'm going to do is I'm going to go ahead and set up, one last thing. It gives the density of H2SO4. All right, so remember the way that this should be interpreted is that it's that many grams of the chemical per exactly 1 milliliter of that. All right, so I'm going to start off with the number of milliliters of H2SO4. All right, and notice I've got it. Again, when you're trying to come up with the strategy for how to do this, remember you're trying to get to the glue relationship as fast as you can. All right. Sometimes you can't get there very quickly, and that's fine. But remember, if you can get there in one step, do it in one step. All right. So I start off with milliliters of H2SO4, which means that I have to have milliliters of H2SO4 down here. All right. So this relationship right here lets me do that. So the next one, I've got grams of H2SO4. I need grams of H2SO4 down here. And this relationship lets me do that. All right. Now I'm set up so that I actually can use the glue relationship because I need to have moles of H2SO4, and that would match right here. All right. So I use that glue relationship. I just flip it upside down. And now I turn my attention. What do I need to get to? Grams of aluminum. And this relationship allows me to get to grams of aluminum. All right, so you plug all those numbers into your calculator. Right, plug those numbers in your calculator and round to 2 significant figures. You choose 2 because the number with the smallest number of significant figures is this one right here, and you get 1.5 grams of aluminum. All right, in the next problem, I'm going to be a little bit quicker. First of all, I'm going to identify the chemicals in this balanced reaction right here that are involved in the question. I've got H2SO4 right here, and I've got sodium hydroxide, which is right here. All right. I can see that the problem mentions something about milligrams of sodium hydroxide. So I'm just going to write down this relationship right here, because I can tell this one's not going to involve the one that involves formula units of sodium hydroxide. All right. I'm writing down the glue relationship. That is the mole to mole relationship between these two chemicals. All right, I'm going to write down, so it involves some other things here, so I'm going to write down some other relationships. I have 1 mole of H2SO4 is 98.08 grams of H2SO4. All right, that comes from just, the molar mass of H2SO4. All right, this relationship comes from the density provided of H2SO4. And one other thing I'm going to note here, the question doesn't ask for grams of NaOH. All right, it asks for milligrams of NaOH. So I'm just going to include this relationship right here. That's just a basic metric conversion saying that there's 1,000 milligrams of anything in a gram of anything. All right, I just put NaOH here. All right, so starting off with what the problem provides, 2 milliliters of H2SO4, and I can take that, and you have 1 milliliter per 1.84 grams. That comes from this relationship right here. All right, you can then insert this relationship right here. Notice we're always keeping the unit and the of what matching diagonally from each other. All right, I can now use the glue relationship. All right, I can now use this relationship right here, which gets me to grams of NaOH. And then I can just insert the last one, which is just, this one just functions as a metric conversion. If you wanted to, you could just stop the crossbar right here and calculate grams of NaOH. And then in a separate step, you could do the metric conversion if you feel more comfortable doing that. All right, either way should work. So one thing I want to point out about this, the way that this problem is actually asked, it would only be assumed to have one significant figure, because this number right here has one significant figure. So this number right here, as it comes out of your calculator, would be rounded to 3,000. All right. In the next problem, what we're going to do, we're going to recycle a bunch of these relationships, and in doing that, you are going to put 14.5 grams of NaOH right here. You're going to, you can then use this relationship right here. All right. You then use the glue relationship. All right. Followed by that, you're going to use this relationship right here, which you just turn upside down. And then since we want to get to milliliters of H2SO4, you just put in, you just take the density relationship, you flip it upside down, and that would give you a number of milliliters. All right, I haven't shown the calculation, but you should be able to take the numbers from the top here, you multiply all those together, and then you divide them by the numbers on the bottom. All right, just skipping ahead here, just 2 more of these. In this problem right here, all right, so again, remember that the assumed units of density are grams per milliliter. All right, so in this problem, it gives you the density right here, 1.49. And so you could just turn that into this density relationship right here. All right, so I'm just going to point out that this is a 1-to-1 in terms of the coefficients of the balanced reaction. I've written the molar mass at the bottom of each of these chemicals, and I'm going to turn these. I'm going to start off the problem with what it provides me with. All right. I then use the density relationship, which is right here. I then use the molar mass relationship, which I can get from right here. All right. The glue relationship I get from pulling out the coefficients of the balanced reaction. The next relationship comes from the molar mass right here. All right. And the next one is just a metric conversion. All right. So again, if you feel more comfortable, I think it's a good idea just to write the relationships down, just kind of like I've done for this right here, and then have them visible when you're trying to set up the crossbar. All right. So This would be rounded to 2 sig figs because this has 2 significant figures right here. And that would end up with giving you 280 milligrams of magnesium. All right, and the last problem, we're just going to recycle some of the problems. So starting with 567 milligrams of magnesium. All right, first I'm going to do a metric conversion. That gets me into grams of magnesium. All right, once I've got grams of magnesium up here, I can use the molar mass conversion like this. All right, I'm now set up to use the glue relationship, 1 mole of this per 1 mole of this right here. And then I'm set up to do to use the molar mass of this chemical right here in the final step. All right, and then just putting that in your calculator, you get 3.66 grams of that chemical. All right, so hopefully that helps, and that's it for this video.